why don't you guys open up your journal to E1. See if you can find E1 for me. E1 is the Meech, actually.
Mr. Ray.
Yeah, what's up?
You didn't get a lunch.
Yeah, I got you, don't worry. All right, so you're going to keep your bubble map right out in front of you. Keep your bubble map right out in front of you there, and then you can get your journals out ready to go. See if I can get my journal caught up to your journal. Well, this will work out well. Perfect. I am now caught up to you. All right, ladies and gentlemen, what we're going to do is, our guest speaker,
Oh, please.
Ms. Scholl,
Yeah.
what's up? What's going on? You come to braid my hair?
Gabby's coming in. She just got to stop at her locker.
Oh, is she? Okay, cool. Thank you very much. Okay, let's try that again.
Okay.
Okay, Trevor's having fun. What we're going to do is we're going to do two things at the same time. One, you're going to share with me what's on your bubble map, and then you're going to steal things from each other to put down on yours, because if you have a nice complete bubble map, I'm going to give it a 10 out of 10 for the portfolio. And at the same time, we're going to grab a couple really key features and throw them into journal entry E1, which is the Meech. Okay, so you should have the Meech sitting in front of you right now. And you should have each of the forms of energy, and I think this class did really well, and they have something already written for every single form, so we should be in pretty good shape. All right, ladies and gentlemen, without further ado, I'm going to run through the Meech step by step. Where are you sitting, Gabby? Here? Okay. I'm going to run through step by step, or form by form, and you guys are going to tell me what you're thinking here. So, ladies and gentlemen, what did you write down for mechanical energy? Is there anything you pulled out of the video that you do need to share? I'm going to wait until I have at least 10 people with their hands in the air, otherwise this is going to be the most boring class ever. So give me something that you wrote down about mechanical energy for me, please. I realize it was an incredibly short video, but I was really impressed by how much information you pulled out of it. Okay. By the way, there's one group in here that didn't do it. Is it you guys? Mm-hmm. So now you're going to be able to steal from everybody else a couple things to write down.
We didn't do electromagnetic.
And yeah, everybody's missing one. You're probably missing mechanical. You're probably missing electrical, electromagnetic, chemical, heat.
No, we're missing nuclear.
Okay, nuclear. You guys must be heat then. Okay, so you can steal stuff from each other as we're talking. All right, mechanical energy. Let's hear it. Give me something that you found from the video. Go.
Potential energy.
Oh yeah, potential. You got to have the word potential energy in your bubble map. If you just want to write it as PE, that's fine from here on out. A capital P, capital E. That's actually how we're going to address potential energy most of the time here. It's a nice short way to write it. So PE is what? Yeah, Andrea, what?
Kinetic thing.
Yep, kinetic energy. Perfect. Which you can simply write as KE if you want. So you want to make sure you have both a PE and KE bubble off there. And we're going to talk about those quite a bit towards the end of this week. What do you think, Noah?
Spinning nucleus of an atom.
Yeah, when you have anything that's moving, like the spinning nucleus of an atom or moving electrons, anything that's moving has mechanical energy. Now, you've written that, or it's in your bubble map somewhere, something about motion, but we also need to add it to the journal. So at this point in time, I'm going to have you add something really simple to the journal, and you'll see why as we move closer to this activity at the end of the class. Near where you have all your information about mechanical energy, I want you to write down anything that is moving. Now, I know that's kind of weird to write it down like that, but you will definitely see why when I give you these demonstrations happening at the end. And I don't care, we could do something really lame. We could have a discussion. Give me examples of things that are moving. And you could be like, a moving dog, a moving cat, a moving grandma, a grandma with a cheetah on her back. You know, you could say all of those things. You could actually talk about things that aren't alive, like a moving car, a moving train. All of those things have mechanical energy. Even things that flow, like flowing water has mechanical energy. Flowing air, wind has mechanical energy. Anything that moves has mechanical energy. There's also this potential stuff, which we'll talk about later this week. Cool. I'm going to move to the next one, though. And hopefully you guys have enough to write down at least 2 or 3 things on the bubble map. Cool. Let's move it forward then. Next up, electrical. Now you guys are missing electrical, so you want to make sure you get some stuff here. What did people see from the video about electrical energy? What did you see? Over here, what did you find in the video there?
Electric charges.
Yeah, definitely deals with electrical charges. If you don't have the word charges, I recommend adding that. Just simply the word charges or electrical charges. We're going to be talking extensively about those. Mr. Neff?
I wrote down magnets.
Yeah, magnets. Magnetism and electricity are related to one another. You can actually make magnets using electrical current, which is pretty cool. That's interesting that you saw that in there. Yeah, Katie.
Magnetic field.
Yep, you can make a magnetic field using electricity. That's awesome stuff. Yeah, over here.
I got that Earth is a giant magnet.
Oh, that's a good one too. Yeah, we're getting into a little bit more of the magnetism, but that is a cool thing. You don't have to write that one down, but it is very interesting. The Earth is actually a giant magnet in a way, and that's something I think most of you already know. It's the reason why compasses work and stuff like that. It has to do with the metal core inside the center of the Earth and the fact that it rotates. A lot of interesting stuff going on in there. Yeah, what's up?
I wrote electrical circuits.
Yeah, you got it. You have electrical circuits. Electricity is able to flow through circuits. These are great things to add. You should have flowing electrons or something like that written down. You should have something like that already written in your journal, flowing electrons. Just for the heck of it, let's add through wires. Now, we're going to change that later on into conductors and stuff like that. But in your journal, make sure that you have flowing electrons.
We have the energy of moving electrons.
That's fine. You definitely want to add through wires, and you'll see why in a little bit. These little circle things are going to help you in the activities you're going to have to do for energy transformations. Did you have something to add?
I wasn't here yesterday.
Okay, so you need to copy that sheet. I've got one right here for you. All right, perfect. Let's keep it on going then. We got electromagnetic energy. Electromagnetic energy is probably the weirdest energy we can talk about. And there's one thing you really need to know about it. And the one thing you really need to know is what our main example is that we're going to use. Somebody know what the main example of electromagnetic energy is that we're going to be using? We were talking about it in Ms. Oakley's math class yesterday. Believe it or not, it's the one we were talking about. What's the example of electromagnetic energy that we are going to use? Yes?
Light.
It's light. Light is our number one example. You're going to want to get that in the journal, that our example is light. But there's lots of other examples too, like radio waves and microwaves and X-rays and all those kind of cool
Wait,
things
is
like
that
that.
what microwaves are?
Microwaves are actually electromagnetic radiation, just like light, except it's light you can't see. Well, hold on. Lots of questions. That's good. Why don't you raise your hand and I'll address them. Okay, yeah, now keep going.
So, I remember like a while ago, someone told me that a microwave doesn't actually get hot, it just like warms stuff up somehow.
It is weird. The way a microwave oven works, we're going to talk about this substantially in a couple weeks, but let me just give you like the quick down and nerdy way to do this. What happens with a microwave oven is you have these waves, just like light waves, just like radio waves. In fact, they are radio waves that cook your food. They're small radio waves. That's why they call it a microwave. And when they hit the molecules inside the food that you put in there, it causes the molecules, like molecules of water, which is H2O. I don't know if you know that. You might know that already. It causes individual molecules of water to start rotating. And as they rotate and vibrate, it makes the food hotter. So it doesn't use like a flame or anything like that, or convection. It actually causes the molecules to actually spin or vibrate, which heats the food,
And
which is weird.
when
what's
they
up?
move, would that make it mechanical?
And then it becomes mechanical energy. That's huge. Heat is actually, if you think about it, mechanical energy, because heat is vibration. And that's where you're starting to get up that high school, college level with understanding that. Yeah, I'm going to work my way this way because we had a couple hands. Go ahead.
I have two things.
Yeah.
Could we write lightning and stuff?
You could write lightning here if you want for electricity, but lightning by itself is usually associated with electricity, not electromagnetic energy, even though lightning would emit light. So you're turning electricity into electromagnetic. I would keep lightning with electrical. But as you'll see, you can change all these things. Yeah, ask your second one.
And
Andrea, you still have
no, I
questions
got
too, right?
I got a thing.
Okay, go.
Milky Way galaxy was in the video. I don't know if we should say that.
For electromagnetic energy?
Mhm.
Probably because you can receive light and radio waves from distant galaxies and stars. That's pretty cool. You can keep that in there. It was probably in that portion of the video, would be my guess. Yeah, over here. What was up?
How come like microwaves only
I'll
warm
move
up?
this. I'm so sorry. This is in your way. Yeah, go ahead.
How come in a microwave it warms up the outside before it warms up the middle?
Yeah, there's a lot of weird things with microwaves. You notice that some things like heat up super fast too? Do you ever put it like a piece of bread in the microwave?
Yeah.
You cook it for like 10 seconds or 15 seconds, it's like stupid hot. okay? But you put water in a microwave, do you ever notice that you have to like heat it for a really long time compared to like a piece of bread? There's a lot of weird stuff going on. We're actually gonna spend an entire day just talking about how microwaves work, believe it or not, when we talk about electromagnetic energy. So it's a really interesting way to heat food, and we'll talk about that quite a bit. And heat cats, which is what the video is about that I'm going to show you, how you can dry off cats using a microwave oven. Do not try that at home because I don't think the cat lives in the video. We'll have to watch all the way to the end to find out. So let's go ahead and check it out. We have mechanical, we have electrical, we have electromagnetic. Our number one thing is light. Nuclear. Now, nuclear chemistry, we're actually going to spend a whole day on also, and I'm going to co-teach that with Mr. Michaud in social studies when we talk about nuclear weapons. But does anybody know where nuclear energy comes from? What is nuclear energy? You got a whole bunch of stuff on your bubble map if you saw the video. What is it? Yeah, Katie, what do you got there?
Fusion or like,
Did you say fusion?
yeah.
Yeah, fusion is pretty cool. Fusion is when you take atoms and you actually get them to combine together, and it releases a huge amount of energy. And that's how we power our nuclear reactors. We actually power bombs that way too, nuclear bombs. By the way, you should write those down. Nuclear power plants, bombs, great example. I usually say I can never say nuclear power plants. I always say it wrong, so if you catch me sometimes if I'm talking too fast, it comes out nuclear powered pants. I don't know why, so I will say that often. I want to get some pants that just say nuclear power down the side and be like, these are my nuclear power pants. But feel free, I don't know, maybe I could try selling, make some money off them. Thank you for smiling at that, that's really lame, but it's true, I'll say it all the time. All right, so nuclear power pants, bombs. What else can you tell me about nuclear energy? Go ahead, yeah.
Nuclear forces hold together atoms.
Oh yeah, in fact, nuclear force is what holds atoms together, and that's a huge amount of force that you can unleash in nuclear power plants and in bombs and such. Yeah, what's going on?
Like, to release, you have to like cut open the nucleus.
Yeah, and you have to split an atom, which is actually known as fission. You had the word, no, did you say fusion or fission?
I don't
You
know.
said fusion.
You said fusion, and fission is when they actually split.
That's what they
it's very
use
cool.
in power plants and bombs.
They use, are you saying power pants too? Now I've thoroughly messed you up. Yes, in plants, now it doesn't even make any sense. In nuclear power plants and bombs, they use fission, which is the breaking apart of atoms. Scientists right now are trying to model what the sun does. The sun actually is a nuclear reaction that's called fusion. Fusion is where atoms join together and release energy, and it's not hot. Like if you wanted to power your iPod with nuclear power, that would not work real well. Because it would be dangerous. It would probably raise to a temperature of thousands of degrees and melt your iPod. It would be very, very difficult. But if scientists can come up with a way to instigate fusion, nuclear fusion, then you can actually probably run something like an iPod at a temperature that's very cold for 50, 60, 70,000 years without changing the battery. If you could get a little nuclear fusion reaction going on. Scientists have been working on that for decades. That's a cool, cool way to go. And that's actually the way that the sun works from the core, anyway. Yeah, what's up? Over here.
That the sun is made up of hydrogen.
Yeah, it's hydrogen that's undergoing fusion in there, which is kind of cool. Yeah, so what should we write down in the journal? In the journal, we want to make sure we have the sun. We should definitely have the sun there as a great example. That's S-U-N, sun. So we got to make sure we have the sun there. We also want to have nuclear power plants. And we definitely want to have bombs in there, too.
Okay, go ahead.
Yes, what's up? Okay, good. I've just been waiting. Once she's gone, we can start the fun stuff. Great, that's enough stuff for me. Make sure you circle them all. Make sure you also have nuclear power plants, and make sure that you have bombs in there. Great, let's continue, and then we will get into this interesting activity, which is coming up probably in about 3 minutes.
Pick that up.
Yep, I got you.
Okay, you're such a nice, caring person. Here we go, ready? There are 3 major types or examples of chemical energy that you guys need to know. Can anybody, looking at the bubble map, come up with any one of the 3 examples of chemical energy that you think I need you to write in your journal? Ooh, I've lost my hands. If I lose my hand, if I have lost my hands, I believe you might be spacing a little bit. Let me try this again. If I'm losing you, then I'm going to have to do kind of like the lame demonstration. I got to know you're with me if I want to do this one that's a little bit more intense. So let me ask my question again and see if we get a little bit more participation here. Chemical energy, the energy stored in atoms. There are 3 examples you need to know of things that contain chemical energy. Do you think you know at least one of them? Because if we can come up with all 3, we'll just go right to the next thing. Now that's what I'm talking about. We got like 10 people there. Yeah, go ahead. Food. That's number 1. You need to know that. You run on chemical energy. You eat food. We also learned that that food gets its energy from the sun. Any food that you eat gets its energy from the sun. Now if you're eating lettuce, that's obvious. If you're eating like a cow, that becomes less obvious. But the cow is eating grass, grass is getting its energy from the sun. One kid in the other class was like, what if you ate a lion? Like, really? Really? That's your question? What if you ate a lion? Some kid said you can't eat lions. Sure, you can eat a lion if you want. But you can't kill a lion. Yes, you get a gun, you shoot a lion, then you eat it. It's pretty easy, okay? If you were to eat a lion, lions eat meat. Well, does that get its energy from the sun? Yes, it's that whole food web, food chain thing that you learned last year. You're eating lion, lion's eating gazelle, gazelle's eating grass, grass is doing what it's energy from the sun. No matter what you do. Even some kid asked me about yogurt. Yogurt? They're like, what about yogurt? Like, what is yogurt? Well, yogurt is obviously you're eating a microorganism. You're eating something that's alive. And the way that you culture it is you actually, this is a weird thing, the way that you culture it is actually by feeding the microorganism that you have, you feed it milk. And then as it eats its way through the milk, it becomes and grows into the organism. And then you are eating that microorganism actually while it's still alive.
Good, I don't
Good.
eat
Oh, I
it.
can ruin all kinds of foods for you if we talk about it.
Hot
long
dogs?
enough. Excellent. Oh, that one ruins itself.
Goldfish.
All right, so let's go ahead and keep going. You eat goldfish? Oh, goldfish like in the package. I was going to say. That's just a little strange, man. Just a little strange.
No, Griffin, no questions.
No questions at this point in time, other than you may go to math to sharpen your pencil. That's fine. Okay, check it out. Next, we got food. That's one that you need to know. We definitely need to know food. There are 2 more we need to know as an example of chemical energy. Food is one and people run on it. Can you give me another? What are you thinking? What are you thinking over here?
I use gas maybe.
Yeah, gasoline.
Yeah.
Now, if you can write fossil fuels if you want, because gasoline, coal, oil, natural gas, all that stuff is all chemical energy. Like cars run on gasoline. Gasoline is chemical energy. And we learned yesterday that that all pretty much comes from the sun too. So I'm just going to write down gas, but really any type of fossil fuel is going to be considered chemical energy. Great, we got one more. One more, it's what like your iPods run on and all those types of things. Your iPods you don't load with gas, okay? Your iPods you don't feed them like carrot sticks and stuff like that. So what's up with the iPod? How's it run? What's it run on? You know? What's it run on? What's it run on? Cool, it runs on electricity, but the electricity's got to come from some energy source in there. Batteries. So let's go ahead and write that one down. Oh, we are there, ladies and gentlemen. In fact, the H, or the heat, I don't even think we need to write down examples of. Because anything that is hot, like we could write down examples like hot bread, hot pockets, hot Pop-Tarts. We could keep going and going and going. Anything that has heat is pretty obvious. What you need to make sure you have on your bubble map is what heat is. What is heat? Because I know I do need you to raise your hand, please. I realize we got a lot of participation, but I really need you to raise your hand, otherwise it gets very confusing for me. Cool, what is heat? Go ahead. Yeah, it's the actual motion of the particle. So if you haven't written that one down for heat, make sure that you say something about vibration or motion of particles, and we should be in great shape. Yes, did you have something else to say? Anybody want to add anything? Okay, here's the deal. I wanted to leave you with 15 minutes in order to do this activity. I have 16, but it's very, 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 I'm right on the edge here. Because as I'm looking, I got like all but like 2 or 3 kids looking at me, listening to my instructions. If I feel like you're starting to talk to each other or doing other things, I'm going to have to run the lame version of this. I really want to use those things, but I got to have you listening and paying attention, otherwise it could be hurt. Okay, so here's what we got. I am going to hit you with 3 different energy transformations. Let me show you what I mean. Here's an example of an energy transformation. You saw one yesterday, and it's hanging out right here. I don't know if this is still plugged in. Hopefully it is. Oh yeah. Did this work for you guys? There were a couple classes it didn't work for. Oh, perfect. So if we get this thing rolling, hopefully it'll be all set. I'm doing an energy transformation. I'm going to go ahead and make this one real simple. You have the Meech sitting in front of you. You have the 6 forms of energy in your journal. What type of energy is wind in the Meech? Raise your hand and tell me. By the way, if I don't have every person with their hand in the air, we got a problem. We got to slow down.
Oh!
Because some of you are like, well, wait, there's no W. There's no W in Meech. What's up with that? If you look at the choices in Meech and what you wrote, what type of energy does wind have in the Meech? Hamrick, what? It has mechanical, because it's moving air. What type of energy are we getting out of it? Take a peek. Don't underestimate how difficult this is, because when I start giving you other examples, it gets tough. But what kind of energy is this?
Electricity.
Great. So here's an energy transformation. It turns mechanical energy into electricity. Now, for you smarty pants out there, and there are many of you in here, we actually took it another step, and we turned it back. We went from mechanical into electrical, and I think in some classes we lit up the light, and it actually, this was one of the classes where it worked. Look at that transformation. Mechanical into electrical, and then into light. Which one's light again? Electromagnetic. So that energy transformation would be mechanical to electrical to electromagnetic. I'm going to give you 3 different things. Watch very carefully how this is going to work. You're going to tell me what the energy transformation is in each one of these things. Now, as I showed you with the steel spheres there, this gets a little dicey and is moderately dangerous, so you're definitely going to have to listen. Okay? One of my groups is going to get these steel spheres. Okay? And I'm going to give it to the group right now that's closest to me. Now, my plan is for every single group to do every single thing. So no worries. If you don't have this, you will be getting it momentarily. Here's my deal with it, though. Every single kid in this group is going to have to be wearing a pair of goggles, even if you are kind of far away from it. Because, again, I had a kid burnt in the eye, all right, years and years and years ago, and a couple kids have been burnt today by doing this demonstration right here. But the goal is to run it and write down what you think the energy transformation is in the Meech. And you're going to be writing that right in your journal. Okay, it's actually going to be our next journal entry. So we got a couple more of these, and we'll go ahead and check them out. These guys over here. Yeah, you can go to your next blank page. I can show you what the journal entry is if you want.
E3.
Yeah, it's E3. It's an energy transformation. And there's the title of it right there. You can write that. These guys over here are going to have radio meters. They have 2 of them. By the way, you are all a large group. Okay, so we'll run you guys as a large group. And then we've got 1 set of the steel spheres for here and 1 for here. So you guys can pass around and do whatever you want there. Over here we have 2 examples of this. We already have a picture of Alexis Leonard having fun right on the front, so it must be awesome, okay, which works out nicely. Let's go ahead and see what we got. Look at that. Okay, there we go. Good comeback. All right, so here's what we got. This right here is a radio meter, and you're given a flashlight, which hopefully will work. Has a little bit of a loose connection in there. We'll go ahead and get that straightened up for you. But you got another one hanging out right there. You're going to take this out, and you're going to shine the flashlight on the radio meter, and then you're going to write down what the energy transformation is that you think is taking place. So that one's hanging out over here. We have 2 of them, 1 for these guys, 1 for these guys. So hopefully we shouldn't have any issues. This is going to be a problem. On that momentarily. And then finally, this table over here actually gets 2 separate things, but you got to be super careful with them to make sure they're working well. This is not a potato puck. Is it currently working? Is there a time on there? It doesn't need to be right. Does it say anything? Okay, cool. This one will come and go. I've already probably used up my chemical energy here, but I'll go ahead and see if I can get it running.
Thank you for the answer.
These guys are going to, well, I didn't give you the whole answer. I gave you part of it. You're going to quickly see I'm not using. Oh, is it actually running? That's disgusting. It's not a potato clock, kids. You'll see what it is when you get it. So these guys right here are going to be using the fruit-powered clock. These guys up here are going to be using the crank, this crank thing right here. You got to be real gentle with this. This will break really easily. So when you start turning it, start off by turning it slowly. Don't turn it spastically. Just turn it slowly, and then if you turn it a little bit faster, you see how this thing works. So what I'm going to do is I'm going to give your group about 2 or 3 minutes. You are going to run whatever it is that you have, and then you're going to write down what the energy transformation is. It's got to be from one form of the Meech to the other, and some of them are relatively easy, but you only have 2 minutes, and everybody in the group can look at it. Like, you can take that one, pass it all the way around to everybody so everybody can try it. You can pass that one around to everybody so everybody can try it. You guys all got to put goggles on the second I say go. Okay, you remember somebody's holding the paper like this, and another person's taking them and going like that. Okay, on either side of the paper. And over here, you guys know what you're doing? Cool, 2 minutes, let's say, starts now.
I wanna do the ball.
Cheers.
Everyone.
I mean,